Hello students, welcome to the EduSet program. Myself Dr. Raman Rani Mittal, lecturer in chemistry from Government Polytechnic College for Girls, Patiala. Today I am going to deliver you a lecture on analysis of water. The main contents of this topic are hard and soft water, types of hardness, degree of hardness, estimation of hardness by EDTA method, chemical analysis of water, estimation of alkalinity, estimation of TDS, estimation of free chlorine, estimation of chloride ions and estimation of dissolved oxygen. Now, all of you know water is essential to all forms of life. It is the principal constituents of Earth's surface. Of the total global water, the oceans and inland saline water contribute to 97.3% and the fresh water amounts to only 2.7%. Unfortunately, most of the fresh water is not easily accessible since it is locked up in glaciers, frozen lakes or under the ground. The fraction of water available for human use is only 0.3% of the total global water supply. Hence, it is the need of the hour to use the available water carefully and economically. Now, let us have a look on hard and soft water. Water is classified into two categories depending upon the behavior towards soap solution. Number 1 soft water, number 2 hard water. Soft water, water which produces lather with soap solution easily is called soft water. Examples are distilled water and rain water. Number 2 hard water, water which does not produce lather with soap solution easily is called hard water. Examples of hard water are river water, sea water, tap water, etc. Now, question arises, what is the causes of the hardness of water? Naturally, hardness of water may be due to certain salts dissolved in it, and these salts are bicarbonates of calcium and magnesium, chlorides of calcium and magnesium, sulfates of calcium and magnesium. So, we can say 6 salts are responsible for hardness of waters: bicarbonates, chlorides and sulfates of calcium and magnesium. The formula of bicarbonates is CaHCO3 twice and magnesium bicarbonate is MgHCO3 twice. Calcium chloride is CaCl2 and magnesium chloride is MgCl2. Sulfates, calcium sulfate and CaSO4, whereas formula of magnesium sulfate is MgSO4. Now, why hard water does not produce lather with soap? It may be certain chemical reaction. So, let us see what is that reaction and what is soap. Hard water does not produce lather with soap solution readily because cations, calcium and magnesium, these ions are present in hardness causing substances. So, these cations, they present in hard water, they react with soap to form insoluble precipitates. Soap, what is soap? Soaps are sodium salts of higher fatty acids like stearic acid C17H35COOH, oleic acid C17H33COOH or palmitic acid C17H31COOH. Now, when soap is added to hard water, the anions of fatty acids present in soap combine with calcium and magnesium ions to form calcium and magnesium salts which are insoluble in water. So, by equation you can see it is soap C17H33COONA, sodium salt of stearic acid, it is called as sodium stearate, it is soap. And this is calcium chloride which is present in hard water. Now, the reaction taking place between the two is that sodium is replaced by calcium ions of the hard water. So, calcium stearate is formed which are curdy white precipitate. Therefore, no leather is produced until all the calcium and magnesium ions are precipitated. This results in the wastage of soap. The soap which had been used for leather formation, that is consumed by hardness causing substance, and there is no more leather formation. Now, types of hardness. Hardness of water is of two types. Number one is temporary hardness, number two permanent hardness. So, first of all, let us have a look on temporary hardness. Temporary hardness is due to the presence of bicarbonates of calcium and magnesium, calcium bicarbonate and magnesium bicarbonate. This is called as the temporary hardness because it can be simply removed by boiling hard water. Now, what happens on boiling? On boiling, bicarbonates of calcium and magnesium are decomposed into carbonates. You can see in this equation, calcium bicarbonate, temporary hardness causing substance. On boiling, it changes into calcium carbonate, water and carbon dioxide being gas, it escapes, whereas calcium carbonate is insoluble, it collects at the bottom of the vessel as white powder. Similarly, magnesium bicarbonate, which is also hardness causing substance, but it causes temporary hardness. On boiling, it changes into magnesium carbonate, which is also insoluble and collects as white powder in the bottom of the vessel, and the other two products are water and carbon dioxide. And when we boil water containing temporary hardness, these two chemicals, these two salts, they are no more and water becomes soft. So, these carbonates being insoluble are removed in the form of precipitates, and thus temporary hardness is removed. The second type of hardness is permanent hardness. Permanent hardness of water is due to the presence of chlorides and sulfates of calcium and magnesium, or we can say calcium chloride, magnesium chloride, calcium sulfate and magnesium sulfate are responsible for permanent hardness. Why it is called as permanent hardness? It is so because it cannot be simply removed by boiling. Now, we come to the other topic, that is the degree of hardness. Degree of hardness means the amount of hardness causing substance present in water. In order to know the hardness of water, it is necessary to know the strength of hardness causing substances present in water. Since there are so many salts responsible for hardness, so in order to compare these hardness of different salts, different samples, so we will have to select one compound, and that compound is calcium carbonate. Hardness of water is expressed in terms of calcium carbonate. The reason for selecting calcium carbonate as a standard is that number one, it is insoluble in water, and number two, molecular mass and equivalent mass of calcium carbonate are 100 and 50 respectively, means molecular mass of calcium carbonate is 100, equivalent mass is 50, and calculations become very easy. Now, the degree of hardness of water. By definition, it is the number of parts by weight of hardness causing substances in terms of equivalents of calcium carbonate present in definite number of parts by weight of water. Means, in simple words, we can say the amount of hardness causing substances or the weight of the hardness causing substances which are converted in terms of calcium carbonate present in certain definite quantity of water is called as the degree of hardness. And naturally, degree of hardness, it can be measured in different units. So, depending upon the units in which degree of hardness is expressed. So, hardness of water is expressed in following 4 types of units. Number 1, parts per million, in shortly we say ppm, Clark's degree of hardness, degree Cl, French degree of hardness represented as degree French, and fourth one is milligrams per liter, mg per L. So, parts per million, what is parts per million? Parts of calcium carbonate equivalent hardness present per 10 raised to power 6 parts of water is called as ppm or parts per million. Means that hardness causing a weight of hardness causing substances in terms of calcium carbonate present in 10 raised to power 6 parts of water is ppm. Similarly, Clark's degree of hardness, weight of hardness causing substances in terms of calcium carbonate present per 70,000 parts of water. Then French degree of hardness, similarly, that weight of hardness causing substances in terms of calcium carbonate present per 100,000 parts of water. And the fourth one is milligram per liter, that number of hardness causing substances in terms of calcium carbonate equivalents present per liter of water. Now, out of these, milligram per liter and ppm, they are the same thing, means they are equivalent. So, how this can be equivalent? Let us have on this, look on this relationship, that 1 milligram per liter, by definition it means 1 milligram of calcium carbonate equivalent hardness in 1 liter of water, means hardness causing substances in terms of calcium carbonate, it is 1 milligram. Now, 1 liter of water is equal to 1 kilogram of water by weight, because density of water is 1 gram per cc, means 1 ml of water weighs 1 gram. So, 1 liter of water weighs 1 kilogram, and 1 kilogram is converted into 1000 grams. And 1000 grams, if they are to be converted into milligrams, so we have to multiply it by 1000. So, 1000 into 1000 milligram of water, or we can say 1 liter of water is equal to 10 raised to power 6 milligram of water. Hence, 1 milligram per liter becomes 1 milligram of calcium carbonate equivalent hardness in 10 raised to power 6 milligram of water. 1 liter of water is replaced by, in terms of weight mass, 10 raised to power 6 milligram. Or we can say 1 part of calcium carbonate equivalent hardness in 10 raised to power 6 milligram of water, and this is the definition of ppm. So, it is equal to 1 ppm. So, we can say 1 milligram per liter is equal to 1 ppm. Now, we have a relationship between the various units. We know that 1 ppm is 1 part per 10 raised to power 6 parts of water. 1 degree French is equal to 1 part per 10 raised to power 5 parts of water, whereas 1 degree Clark is equal to 1 part per 70,000 parts of water. So, we can say 10 raised to power 6 ppm, that is equal to 10 raised to power 5 degree French, and that is equal to 70,000 degree Clark. Or simplifying it, 1 ppm becomes equal to 0.1 degree French, this is equal to 0.07 degree Clark. So, we can convert, if we have measured degree of hardness in one type of unit, so we can convert into the another units by using this relationship. So, now we have the another topic, estimation of hardness of water by EDTA method. However, we can measure hardness of water, estimate hardness of water by two other method also. These are soap titration method and O-Henner's method, but we will discuss here only EDTA method. So, what is EDTA? We will discuss just now. Let us have look on this method. It is the most common method. In this method, following solutions are required. We require these three solutions. Number 1, standard solution of disodium salt of ethylene diamine tetraacetic acid, commonly known as EDTA. Buffer solution of ammonium chloride and ammonium hydroxide, and indicator eriochrome black tea, commonly known as EBT, as indicator. Now, what is EDTA? This is the formula of EDTA. So, ethylene, full form of EDTA is ethylene diamine tetraacetic acid. So, ethylene, diamine, 2 nitrogens are here, diamine, tetra means 4 acetic acid groups. So, these are acetic acid group, first 1, 2, 3 and 4. So, it is one of the most important reagents in modern analytical chemistry. Now, what is the theory behind this method? How we can estimate hardness? When hard water is titrated against EDTA solution, it forms complexes with calcium or magnesium ions present in water, hard water. Means that EDTA is a complex forming reagent. So, it easily forms complexes with ions like calcium or magnesium, and these two ions are present in hard water, and when we titrate hard water with EDTA. So, EDTA will combine with the calcium ions of hardness causing substances as calcium EDTA complex or with magnesium as Mg EDTA complex. On the other hand, indicator which is Eriochrome black tea or ABT, it is blue in color. It is when added into hard water at a pH of 10, it combines with few of calcium or magnesium ions to form a weak complex which is wine red in color. Means that when we add in blue colored indicator, the solution, hard water solution will become wine red in color. This is due to the combination of indicator with these ions which are present in hard water. So, you can see here that calcium ions of hard water, EBT is the indicator, calcium EBT complex form. Similarly, if magnesium ions are present, this EBT which is blue in color, it forms magnesium EBT complex which is wine red in color. As we are using few drops of EDTA, so only few of the calcium and magnesium ions present in hard water, they will be able to form this type of complex. The solution is titrated against EDTA solution at the end point, because when we titrate this solution, hard water solution against EDTA, EDTA will form, it will go on forming complex like this calcium and EDTA complex, yeah, Mg EDTA complex. But when there are no more calcium and magnesium ions, means that all the calcium and magnesium ions are finished, they are consumed by EDTA, then this EDTA will attack on indicator metal complex. At the end point, metal indicator complex is broken down by EDTA, and when this complex is broken down, indicator is left free. So, blue color is restored. So, the end point is wine red to blue. So, you can see here that firstly EDTA is forming all the magnesium EDTA complex or Mg EDTA complex, but at the end point then this EDTA will attack on this complex calcium EBT complex or magnesium EBT complex, and it will form calcium EDTA complex, whereas this indicator is liberated and blue color is restored. So, we can say this is the end point. So, similarly, you can see here magnesium EBT complex and EDTA, magnesium EDTA complex is formed and EDTA is, our indicator is liberated. The change of color of this solution from wine red to blue is the end point. So, procedure, how we will perform this titration, various steps involved in this method are: number 1, preparation of standard hard water, number 2, standardization of EDTA solution, and then titration of sample hard water. Sample hard water stands for that the water for which hardness is to be estimated. So, first of all, preparation of standard hard water. How we can prepare standard hard water? Standard hard water stands for that water whose hardness is known, or that's water which we will prepare by ourselves. So, how we can prepare this standard hard water? Take 1 gram of dry calcium carbonate and dissolve it in minimum quantity of dilute HCl. Evaporate it to dryness, that the solution is heated and it is evaporated to dryness. As we have taken dry calcium carbonate and it is dissolved in dilute HCl, the reaction of the two will convert calcium carbonate into calcium chloride. Calcium chloride is a hardness causing substance. So, dissolve the residue. Residue means the white powder which is left behind after dryness. It is dissolved in distilled water and the volume of the solution is make 1 liter. Now, we have now this is the standard hard water. So, what is its composition? As the volume of solution is 1 liter means 1000 ml. So, we will say 1000 ml of solution contains how much of calcium carbonate? Initially we had taken 1 gram. So, we will say it is 1 gram of calcium carbonate or it is equal to 1000 milligram of calcium carbonate and 1 ml of solution contains now 1 milligram of calcium carbonate. So, thus water containing 1 milligram of calcium carbonate in 1 ml is called as the standard hard water. As its hardness is known, so it is called as the standard hard water. Now, standardization of EDTA solution. EDTA solution is prepared, it is taken in a burette, fill the burette with EDTA solution, take 50 ml of standard hard water which we have prepared in step 1 in a conical flask. To this standard hard water add 10 to 15 ml of buffer solution. Buffer solution is a mixture of ammonium hydroxide and ammonium chloride and 5 drops of indicator Eriochrome black tea. The solution will become blue. Titrate with EDTA solution. At the end point, wine red color of solution changes to blue. So, this is called as the end point. Note the volume of EDTA used. Let the volume of EDTA solution used be V1 ml. Now, we will take sample hard water, the water whose hardness is to be determined. So, this is the titration of sample hard water. So, first of all we will determine total hardness. Total hardness stands for the sum of permanent and temporary hardness. So, first step is to determine total hardness. Titrate 50 ml of sample hard water in the same way as in step 2. The titration which we have done in previous step, in the same way we will titrate sample hard water to determine total hardness. And note down the volume of EDTA used. Let the volume of EDTA solution used be V2 ml. The step 2 is to determine permanent hardness. In the previous step we have determined total hardness and now we have to determine permanent hardness. So, it can be determined by boiling sample hard water, because on boiling temporary hardness will be removed and the water which will be left behind, that will contain only permanent hardness causing substances. So, for this take 250 ml of sample hard water, boil it till volume is reduced to 50 ml. Filter in a measuring flask and make the volume 250 ml by adding only distilled water, and take 50 ml of this boiled water and titrate against EDTA solution as we have done previously. Note down the volume of the EDTA used, let the volume of EDTA used be V3 ml. Now, we will do calculations. All of you know 1 ml of standard hard water which we had prepared first of all, that contains 1 milligram of calcium carbonate. Now, calculations of standardization of EDTA solution. V1 ml of EDTA solution were used to titrate 50 ml of standard hard water. Because we had taken 50 ml of standard hard water, it was titrated against EDTA solution, volume used was V1 ml. So, V1 ml of EDTA solution is equal to 50 ml of standard hard water, and we know 1 ml of standard hard water is equal to 1 milligram of calcium carbonate. So, this is equal to 50 milligram of calcium carbonate. Hence, 1 ml of EDTA solution will be equal to 50 upon V1 milligram of calcium carbonate. So, this is the standardization of EDTA solution. Now, calculations for determination of total hardness, volume of sample hard water taken for each titration was 50 ml, volume of EDTA used is equal to V2 ml. Since 1 ml, you can see here 1 ml of EDTA solution is equal to 50 upon V1 milligram of calcium carbonate. We will use this equation. 1 ml of EDTA solution is equal to 50 upon 1 V1 mg of calcium carbonate. So, as in this step V2 ml is used. So, V2 ml of EDTA solution will be equal to 50 upon V1 into V2 milligram of calcium carbonate. Since 50 ml of sample hard water is equal to V2 ml of EDTA and V2 ml is equal to, you can see in the previous V2 ml of EDTA is equal to 50 into V2 upon V1. Put this value V2 into 50 upon V1 milligram of calcium carbonate, means that V2 ml of EDTA solution, this is equal to, in terms of calcium carbonate, V2 into 50 upon V1. Now, 1000 ml of sample hard water will be equal to V2 into 50 upon V1 into 1000 upon 50 milligram of calcium carbonate. So, V2 upon V1 into 1000 milligram of calcium carbonate. So, this much milligram of calcium carbonate are present per liter of sample hard water. So, this is the total hardness. So, total hardness V2 upon V1 into 1000. So, milligram per liter or V2 upon V1 into 1000 ppm. Determination of permanent hardness. So, we have taken for permanent hardness boiled sample hard water. So, volume taken for each titration is 50 ml, volume of EDTA solution is V3 ml. Now, 50 ml of boiled hard water is equal to V3 ml of EDTA and 1 ml of EDTA, all of you know that is equal to 50 upon V1. So, we can say this is equal to V3 into 50 upon V1 milligram of calcium carbonate. 1 ml of boiled hard water is equal to V3 into 50 upon V1 into 1 upon 50 milligram of calcium carbonate. 1000 ml of boiled hard water will be equal to V3 into 50 upon V1 into 1000 upon V1 50 milligram of calcium carbonate. 50 is cancelled by 50. So, this becomes V3 upon V1 into 1000 milligram of calcium carbonate. Since this much of hardness is present in as milligrams of calcium carbonate in 1000 ml. So, this is milligram per liter. So, permanent hardness of water is V3 upon V1 into 1000 milligram per liter, because we had taken 1000 ml. So, because all of you know milligram per liter is equal to ppm. So, V3 upon V1 into 1000 ppm. So, determination of temporary hardness can be determined by subtracting permanent hardness from total hardness. So, temporary hardness is equal to total hardness minus permanent hardness. Mathematically, total hardness which we had determined just now, V2 upon V1 into 1000, permanent is V3 upon V1 into 1000. 1000 comes out to be common, V2 upon V1 minus V3 upon V1 ppm, or 1000 into V2 minus V3 upon V1 ppm. So, this is the temporary hardness of water. Now, we come to chemical analysis of water. Quantitative estimation of various constituents present in water by chemical methods is called as the chemical analysis. Water may contain dissolved gases like oxygen, chlorine, carbon dioxide, and dissolved salts like carbonates, bicarbonates, and chlorides of alkali metals, etc. Thus, chemical analysis of water involves estimation of alkalinity, estimation of total dissolved solids, estimation of free chlorine, estimation of chloride ions, and estimation of dissolved oxygen. So, first of all, estimation of alkalinity. Alkalinity of water is due to hydroxides, carbonates and bicarbonates of sodium, potassium, calcium present in water. So, when certain salts like this, sodium hydroxide, potassium hydroxide, sodium carbonate, calcium bicarbonate are present in water, they make water alkaline or basic in nature. So, in terms of anions, we can say alkalinity of water is due to the presence of